Hello everyone, today we are going to be discussing lipoprotein profile in a deeper resolution. So in a previous video we talked about an analogy of lipoprotein profile to traffic, and that kind of walked through a broad explanation of the kinds of vehicles that are on the road, roadside assistance, the size of the vehicles, the passengers, and so forth. Well, here we're going to explain that in a much more thorough detail. So on the screen here you can see I've outlined HDL in blue, LDL in yellow, and VLDL in red. IDL is still in white. It's just kind of the intermediate density lipoprotein. It's kind of a phase transition from VLDL to LDL. Focusing on liver-derived lipoproteins here, we have ApoB and ApoA. The HDL vehicles are somewhat akin to garbage trucks. So essentially what their job is to take cholesterol from the periphery, either in a lesion in the artery wall or from the liver, from LDL, to circulate that to sex organs for steroid synthesis or other tissues for cholesterol that may need it and they can't synthesize enough themselves. That's generally why HDL is considered a good cholesterol, because the lipoprotein is taking cholesterol away from tissues and to the liver for destruction or to the sex organs for steroid synthesis. Reverse cholesterol transport is the name of its game. Next up, the LDL, as you can see, has a variety of different sizes. So these cars go from, let's say, a Fiat, which is considered to be kind of a more atherogenic particle. The smaller it is, the more likely it has to actually generate an atheroma or get involved in foam cell generation within a plaque. But really, it's important to recognize that the endothelial junction that these plaques form in, it's only 3 to 6 nanometers across. So you can see that I've written here the size of an LDL particle ranges between 20 and 30 nanometers. If the size of the junction between endothelial cells is only 3 to 6 nanometers, you can rationalize that, okay, that's not going to get in there just because it's hindered by its size. So how does it get in there? Well, that's where inflammation and vascular stress actually comes into play to allow for LDL to be disposed of in the vascular wall. Moving on to the VLDL, these are large particles that are made mostly of triglyceride to transport for energy and fuel, and really only have a part to play in atherosclerosis in the context of insulin resistance or some genetic variants that have issues with the disposal of the particles once they're made. So they're more so a recycling issue than an actual issue with the particle itself. If the particles are not recycled, there is an issue because it circulates more and more, and it has more potential to actually get oxidized and changed to where it has more atherogenic potential. It gets recognized less by the liver to pick it up and clear it. And so, again, more plasma residence time equals greater chance for deposition into the artery. So at the end of the day, when we're talking about our traffic scenario, we have small cars with passengers, we have larger cars with passengers, and we have a kind of vehicle system to repair or to provide roadside assistance in the case that there is damage, and that would be the HDL. The main take-home point here is that the cholesterol and the particles or the vehicles that carry it is not the main offender. It just so happens to be there at the time where there is inflammation or some other kind of tissue damage in the site of the vasculature that ends up having an immune reaction where the white blood cells will come in, take up the cholesterol, and take it into that vascular space and create the atheroma or the generation of a plaque. So stepping back, it is vascular disruption or endothelial dysfunction that leads to the ability for cholesterol to then go into the vascular space and create atherosclerosis. All right, so to bring this down to earth with a more practical example, we have a lab result here with a client of ours that has some lipoprotein dysfunction. And first and foremost, you see an elevation in total cholesterol. So this is the number of total passengers on this person's roads. And that is going to be broken up into the amount being carried in the HDL particles and the amount carried in the LDL particles. Now, we're going to focus more on the LDL particles just because they have more of an association with atherosclerotic risk in terms of lipoprotein profile. That number can be found right here. So the LDLP, lipoprotein particle number, 2,075 nanomoles per liter. Now, what that means essentially is you have a breakdown of what kind of vehicle is carrying those passengers. So for example, you have a certain mass, 138 milligrams of cholesterol, and that is being carried in a certain amount of vehicles. Now, for all intents and purposes, those vehicles could be very large or they can be very small and just have a larger number of them. When all is said and done, the amount of passengers in those vehicles is still the same, but you have more of the vehicles on the road. And because there are more vehicles on the road, and because they will be of a smaller size, they have a higher chance of causing wrecks and otherwise damage to the vasculature. So really, the increased likelihood of generating an atherosclerotic lesion is due to the fact of higher number of vehicles on the road in combination with the potential for poor weather conditions and poor road conditions. So to follow up with that, the next profile we're going to look at is the VLDL and triglyceride metabolism. So looking at this person's total triglyceride number, 112, that's going to be relayed into, scrolling down to the next page, the number of VLDL particles. Now, this lab only gives us the amount of large, very low density lipoprotein particles, but that's still a really good assay for potential insulin resistance and hyperglycemia in individuals that may not have it showing up in their blood glucose or their A1C. So this is a really good metric to kind of find out how someone's lipid metabolism is going under the hood, even though it's not necessarily related to the lipoprotein profile in general. So it kind of speaks to this underlying pathology that yields a higher atherosclerotic risk in terms of more VLDL particles, vehicles on the road that have a higher likelihood of getting oxidized and a poor delivery system for those triglycerides that are needed for fuel and for energy generation. So to wrap it all up with our lipoprotein profile, again, it's great to understand the amount of vehicles that are on the road, what the demographics of the vehicles are, but it has to be taken in relation to road conditions and weather conditions, especially when it comes to someone's age and the amount of time they've probably spent with those vehicles and with those conditions. Thanks for watching.